Ella's gone today, and that's it. Okay. But this way they can keep track of what's going on. Oh, my tape fell. But, do you guys remember the beginning of chapter 5? What's going on? Ooh, there were some formulas. And then what were we doing with the trig? What were we learning how to do?
Make it into something else.
Yeah. Do math to it. Change it, transform it. Take nasty, hard expressions and make them simple. And you might not have known why. Now hold on, real quick, before that. Didn't we also go on to do T-proofs like they told us where to get to? Yes. And to be honest, in a way they were telling us that's a worse form and that's a better form, even though you didn't know why. We're going to get to see the why starting in section 5.3. Because in section 5.3, you don't just have something like, I don't like that one. Where was the other one I just had? This one? Nope. This one? Yes. You don't just have an expression. But instead, section 5.3, you have an equation. Let me show you kind of what I mean by that. In section 5.3, it's going to do something like equals 2, and it's going to say solve. You're like, how do you get beta by itself? Right? Look at that beginning. Wait. Look at the beginning right here. How do you get beta by itself?
Exactly.
Let's go back to Christmas vacation, right?
Amen.
Now, wait. So this is bad. But if we take this nasty side and say, no, we can do stuff. Question. What if we get to here? We start here and we're like, oh, it's impossible. I don't know. Literally, I don't know. Me, teacher, don't know. But if we change it, oh, I know now. Why? If secant is 2, who else is 2? 1 over cosine. If 1 over cosine is 2, question. What's just plain old cosine? Right? Plain old cosine, without the division bar. He stuck around. Plain old cosine will be 1/2, right? Wait a minute. Unit circle cosine 1/2, is that a thing? Yeah. Where? Shake off the cobwebs. Where? Cosine, adjacent.
60 degrees.
The x. 60 degrees, or pi over 3. Where else? Ooh, there's another place. No, that's negative. No, that's negative.
Negative pi over 3.
Negative pi over 3. Or negative 60. Or 5 pi over 1 and 4. For cosine inverse, we only choose one, but I'm saying there are maybe more where it's true too. But yeah, cosine inverse, if you did it, there'd only be one, right, Luca? That'd be quadrants 1 and 2. Anyway, question, do we see any of this in sections 5.1, 5.2? Nope. None of the equations, but what did we learn? How to make an unsolvable side into a solvable side. What? Huh. So what if I was to go back to the one that we just looked at a second ago? Where was it? This one? Yeah. Why is this the unsolvable side and this the solvable side? Let's say this was equal to, I don't know, 0. If this is equal to 0, how do you solve? I don't know. There's betas in 2 places. But what if this is equal to 0? How do we solve? Oh, subtract the 1, divide the negative 2, plus or minus square root, go. So let's go ahead and go check out section 5.3. Guys, 5.1 and 5.2, they're not gone. They're not obsolete, sadly. They're still important. However, we're going to get to practice them as we do 5.3. Sound good? We're going to get to practice them as we do 5.3. Now, real quick, just so you know what's coming. If we're already in 5.3, what's coming even closer than if we were in 5.1? A test. Now, dilemma with a test coming. What's it going to be on? Just 5.3 to 5.6, which is kind of hard. I'm going to put in some easy stuff from 5.1, 5.2. Now, maybe not like a crazy T-proof that you guys worked super, super hard in your groups and it was impossible until I fixed it, but maybe not like that. But I'll put some easy stuff from 5.1, 5.2 so that you don't just have hard problems, but wait. Did you just see that huge chart of formulas?
Yeah. Oh, we're going to have a formula?
Guess what's coming in 5, 4, 5, 5, 5, 6 even more?
More formulas.
Stink. So in one day on one test, we're going to have to know formulas and do problems? No. 2 different days. 2 different parts of the test.
Oh.
Listen. Day 1, you're going to have formula part of the test, which is literally one side, one page. I give you, for that big old table, the left side and all the new formulas we learned, the left side with an equals, and you fill in. Done. So what maybe should you start doing now? Quizlet, formula cards, right?
Oh, so it's gonna be like
Flashcards. Yeah, I'm going to write out all the left sides. Maybe some categories I'll give you 2 instead of all 6. But for pretty much every single category, I'll give you some of the left sides and say, give me the other, fill in. So I say something like quotient property, tangent of u equals, and you give me sine of u over cosine of u. Does that make sense? It's all typed out. I have it ready for you. That's day 1. You just need to memorize. If that's a struggle, start now. If that's easy, start now, but maybe not as intensely. Okay, that's day 1. Why am I doing that? They're important. But also on day 2, if I've already quizzed you on the formulas, and I give you the problems, what can I give you as well? All the formulas. So, yeah. So, in homework, do you need to be racking your brain and beating yourself up in a certain problem for, oh, I didn't know that formula, I had to look it up in my notes? No, that's what you're going to get on the test, for Pete's sake, right? Have your notes, have all the formulas, maybe make a formula page and add to it as we keep going and use it for your formula, or for your homework, and be like, sweet, this is what I get on the test. Sound good? Okay, here we go. Section 5.3, I just wanted to make sure you guys knew what was coming, so you knew how to be focusing already, even though homework is due on Friday. Questions on the board. Say, solve. However, do you guys notice that there are, even though each of them say solve, 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 solving. They're asking kind of for 3 different types of answers. You might not know that yet, but you'll know it in a second. The first one says solve with trig inverse. Uh-oh, let's review. Which inverse am I going to have to use for this little baby equation? Sine inverse. So let's think about sine inverse for just 1 second. Do you guys remember sine inverse's domain?
Between negative pi over 2 and negative pi over 2.
Close. That's range.
Oh. Oh, 1 and 0.
Close. There is a 1.
Negative 1.
Negative 1 and 1.
Oh.
Because remember,
Oh, yeah.
inverse says, give me the values, unit circle, as low as it goes, negative 1, as high as it goes, 1, you have 1/2, root 3 over 2, root 2 over 2 in between. Domain says what's allowed to go in, ratios, and range says what's allowed to come out, angles. And remember, if we're looking at like a unit circle, we're only allowed to look in quadrants, 1 up 90, and quadrant 4 down 90. Up pi over 2, down pi over 2. Why am I saying this? It's been a while and you had a Christmas break. Okay, so how do I solve for x? In that expression? Yeah, use the chart, but if it says with trig inverse, technically it says take sine inverse of both sides. Now the 1/2 right now, the way it's written, if I wrote sine inverse, it's going to look really funky, so hold on, let me go ahead and move this just a bit and say sine inverse of 1/2. Okay. On the left side, what happens with sine inverse of sine?
Cut off.
Ultimately, basically, remember there were some weird things that happened, but if they're saying solve with trig inverse, they're saying go for it. I can cancel out and say, sweet, I'm left with x. On the other side, I have to go to the unit circle and ask myself the question, when is sine 1/2 here or here? Positive, first quadrant or fourth quadrant? First. Okay, I know it's between 0 and 90. Sine is 1/2. Would that be 45? No, that's a root 2 over 2. It's either 30 or it's 60. Sine is the y. 30 or 60, which one just goes up a little bit? So 30. 4 pi over 6. Inverse trig gives me one principal answer. I just wrote it in degrees and radians. Done. Cool? Now we have to remember unit circle. Maybe add that to your list to study. Okay. What's different about the second one? Wait, they're changing the game. Now they're not changing that I need to do sine inverse. It's still a sine of x equals 1/2, but they're changing what answers I'm looking for. Sine inverse says only look here. So if they say solve the trig inverse, I only get one answer, but they just changed it and said, no, forget that. Use our angles. And what angles are they saying now? Negative pi, isn't that the third and fourth quadrant? And positive pi. Oh my goodness, they're saying look everywhere. Right? They're saying look everywhere. So am I just going to have one answer? No, maybe I'll have two. Where is sine positive? Exactly. Quadrants 1 and 2. All are positive and sine is positive. So forget these ones for this problem. The sine equals 1/2. Where does sine equal 1/2? Well, is this still an answer? Yeah. But who else? Not 60, remember that's sine equals root 3 over 2. But the 30 degree in the second quadrant, careful, 150, 180 minus 30. The same referencing. So I'm going to say x equals, now it gets a little more exciting. I have pi over 6, 5 pi over 6, or 30 degrees and 150 degrees. Piece of that.
It's the same question.
Because it said to look in all the way to pi. It didn't want me to stop at pi over 2. And sine is positive 1/2, not only in the first quadrant, all students, but sine is also positive in the second quadrant. So I need to go get the other angle too. Again, 7 pi.
Isn't this that one, but as it's for all angles, you do like
Luke is looking at the third one, by the way.
30 plus 360 times n?
Because what's the difference of the third direction? First one says just find me one. Second one says, I don't know, find me however many are in our angles, negative pi to pi in that one. This one says find me everybody. What? How can there be more than 2? You can keep rotating. See. So how many are there? Infinitely many. We're going to write infinitely many answers? Well, we are, but in a formula instead, right? So we're going to say, okay, cool. We know x equals pi over 6 or 5 pi over 6 if we're doing radians. Do you guys notice I'm just writing both sets of answers? It's whichever one you choose. Is that okay? Unless the book only has degrees or only has radians. Okay, so there's a big old fat or. We steal the ones that we found going around the unit circle once. And we say, oh wait, but what if we go around the unit circle twice? Or 3 times, or 4 times, or 5 times? Stink. Do you guys remember the relationship between an angle and all of its coterminal angles? 2 pi away, multiples of 2 pi, or multiples if you're in degrees of 360. So for the radian ones, I say sweet, plus all the other ones. That's what 2 pi n does. Remember, n 0, 1, 2, 3. Different multiples of 2 pi, or negative multiples, because you can rotate. All the radian ones just add 2 pi n, and all the degree ones add 360 n. Remember, both of these are sufficient. It just depends on what mode they want it in, and if they don't tell you, well, fine, just pick one. And you should be able to compare and notice that that's the same as this is the same as that, just in a different mode. Is that cool? Ish. And what am I introducing you to? Weren't these all equations that needed to be solved? But were the directions asking for possibly different forms of answers? Yes. However, do you notice that some things stayed the same? Some things stayed the same. If the directions change the rules, well, you might have some more or fewer answers. And if they say all, well, you better have an n in there because there's infinitely many. Does that make sense? Can anybody think of an equation where the answer would be none?
Between 0 and negative pi.
It wouldn't work for this, but if I gave a new equation, sine of x equals negative 1/2, then I'd have answers there. What would be an impossible equation?
Oh, when if you have like 3 over 2. then-
Yeah. What if sine of x equaled 3 over 2? Is that possible? Sine only goes up to 1. So could there be an impossible equation every now and then? I suppose. But not very often. Let's keep going. Now, you don't have to write this down. Unless you want to just say, finding, visualizing solutions, and write down, you can use graphs or you can use the unit circle. But I wouldn't write all the illustration down. Here's the difference. Which one did we just use to figure out when sine was 1/2? Yeah, we thought unit circle. What's this showing? They graphed the sinusoid, which you could do in your calculator. But there's another graph. Is that the sinusoidal axis? Who is that? Y equals.
Oh, it's the continuous. It's for all of
Look,
the third one.
they graphed this one as one equation, and they graphed this one 1/2 as another equation, and they say, hey, guess what? All the answers are going to happen every time there's a what? Intersection. So Jesse, this is when you were saying like, hey, we use our calculators. They might actually have you practice the skill of, hey, use a grapher, aka graph the left as one equation, graph the right as another equation, find the intersections, and those are the answers. Now, if you're in radians, is your calculator going to tell you pi over 6? It's going to be an ugly decimal that you don't really know what it is unless you go pi over 1, pi over 2, pi over 3, and you're like, I found it at pi over 6. So just a warning, remember calculator gives you nasty answers, that's why unit circle is preferred if we can, but what if they were to give you sine of 2/5? Could we use unit circle for 2/5? We can only do root 3 over 2, root 2 over 2, 1/2, 0, 1. Unless it's tangent and secant, then we can flip them all, right? There we go. So, steps. Let me give you a second. I've given you the background as to how to read the question and how to know what answers are going to look like. So far, all I've helped you on. How to read the question. How to know what your answers should look like. Approximately how many, whether or not there's a plus 2 pi n or not. And the second to last step, whether to think unit circle or calculator. The struggle is, we haven't talked about what if it starts in an impossible form. That's when we go back to 5152 and say, if it starts in an impossible form, we might have to use all those formula, plugging in, doing some math, common denominator-y skills to even get to where we could start solving. Let me pause and be quiet and let you guys write just for a little bit. Are we quiet because we're tired or because we're focused? Both. I'm feeling you, I'm feeling you. Is anybody else bugged by the spacing? I apologize. Are we close? Oh, a couple more seconds. Multitaskers, any good presents for Christmas? A lot of money. Money's good. Games are good. Anybody else get money? That's it? Games? A watch? Are you wearing it?
Yeah.
Nice. That looks cool. Huh?
It's because we did like Secret Santa.
Oh, yeah. What'd she get you?
She got me a card pink.
That's a good one. Ha! I see pencil stopped. There we go. Okay, hold on. Question. All right, I know. I got you off topic. But everyone at least finished. Okay, so, is this go straight to the unit circle, go straight to the calculator, or maybe do some math stuff first? Yeah. What math? What algebra? Yeah, right?
Oh yeah.
Get the cosines on one side. Ready, set, go. Now, could you add this one over? Sure. Could you subtract that one over? Sure. Try to get cosine alone. And if you guys look at the steps in the last page, the first step is get the trig alone as much as possible. You might have to use formulas for it. But this one, get the trig alone. It's as easy as... What'd you guys do? Add this one or subtract that one? Subtract? Adding works too, either way. Uh-oh, let's see if you guys remembered your basic math skills. This is a common mistake ever since, I don't know, forever. That cancels. 1 equals 0. No. -2 cosine, right? A negative minus, a negative plus a negative. There are 2 of them. Just making sure we didn't make that common mistake. Now, don't judge. If we want to solve for x, divide by 2 cos. What's cos? Yeah, we can't divide by cos. That's like a thing that's stuck, right? But we can divide by a -2. Yeah? So I can put the negative out here because it's dividing by a negative. Wait. Cosine equals -1/2. Isn't that a thing? That is a thing. That's a unit circle thing, yeah? Okay, so hold on. As I painstakingly on my mouse write cosine of x equals -1/2, I want you guys to think cosine 1/2 negative. What quadrants? Now, are they asking for some or all? Uh-oh. Do you guys see it? Ooh, okay, hold on. Look at the beginning of your notes. Which direction, which types of answers were answering the all question? Yeah, the 360n, 2 pi n ones. So we have to add 360n or 2 pi n to something. So we have to figure out what the something is. So question, in the unit circle now, there might be some different ways of writing it. And they're not asking for one, so we don't have to be perfect necessarily in all having matching answers. But we do need to figure out where is cosine negative. Quadrants 3 and 4. And more specifically, where is cosine? Wait, cosine's not. No. Struggle. Where's cosine?
2 and 3.
Okay, 2 and 3. Good catch. 2 and 3. Now, what reference angle has cosine being a 1/2?
60 degrees.
60 and 60. What angles are those? Now, now, you get to choose. But would you rather go up positively to hit both, negatively to hit both, or positive for one, negative for one? You get to choose, technically. Positive to both? Okay. So if we go positive to both, what positive angle is the 60 degree in the second quadrant? 2 pi over 3, or if you like degrees, that would be 120, right? 260 degrees. Now I'm going to go ahead and say, hey, you and all of your coterminals, so I'm going to go ahead, since I'm in radian, to put 2 pi n. Would it work if I put 360 right now? No, I have the angle and radians. They have to match. Now that's one answer of a question. Is that enough? If they want all, no. Now here was my question. We could also go negative 2 pi over 3 and be done. Or we could go positively to get the next one, 4 pi over 3. Either one is okay. Negative 2 pi over 3 is good, or 4 pi over 3 is also good. They talk about the same location. You'll end up with the same answers if you need them. Yeah.
So you're saying if we do it in degrees, it'd be 120 plus 360.
Plus 360n. And then, guys, what would the other one in degrees be? It could be negative 120, or if you went positively, 120, 180, 240.
Negative 240.
Positive 240. Because you would go 60, 120, 180, 240. Or you could just go negative 120, the negative little one. Does that make sense? Okay. And then plus 360. So what was the first thing we had to do? Some math, some algebra. Get the cosine alone. But was the algebra crazy hard just to add or subtract it? No. First of all, directions. What are you looking for? What are they going to see, or what are you going to put in the answers? An n, right? All. You need a plus 2 pi n or plus 360n. But before we ever get there, oh, we can't solve this thing unless we, He's unsolvable right now, right? I have x in 2 different places. One's in a sine squared, one's in a cosine squared. Ah, stink. We have to go back to 5, 1, 5, 2 and say we need to change this guy up because he's not cutting it the way he is. Not that we're advocating for conformity, but we do need to make it possible. Ideas? Subtraction? Square rooting? Maybe.
But if you do,
Divide by cosine squared.
I see 2 tangents there.
Okay, hold on. Luke is saying something about tangent. Karina's saying something about dividing. Sean was thinking something about... Ooh.
Divide, you get.
Yeah, I like it. What are they thinking? They're thinking, let's get rid of somebody. Not the 3, that's not going to help. But let's try to get maybe all the trig on one side. And what we do to one side, what are we going to do, guys? Right? And on the right side, it's going to cancel, yeah? On the left side, that's a thing. Why was Lucas saying tangent? And why were Sean and Karina saying divide? Sine squared over cosine squared is tangent squared. Hey, so you didn't forget everything. Because sine over cosine is tangent, and since everybody's squared, it's legal. Equals 3. Well, now we have the trig alone-ish, but I still need to solve. Do I divide by tan squared and leave a little x there, just chilling? No, totally illegal, remember?
Is getting secant squared of x minus 1 going to help?
I don't know, would you guys rather be looking for secants or tangents? Yeah, I think...
Because then you go just for the
Oh, for cosine, that's true.
And then
Do you guys
the
want to go
negative
secant?
one
We
is gonna
can.
go to the other side.
It's up to you. Stick with let's stick with tangent for now, but I like it's a good idea. Yeah, it's a good idea. Okay, so tangent squared. Actually, let me go ahead and clone it because Luca did have a good idea and we can see what he meant. But some of you are like, that's a gross property, I don't like it. Okay, so question, how do we get tangent alone? Well, we got to get rid of the squared, right? But don't we have to say plus or minus because we're doing all the work? They didn't tell us whether plus or minus, so I need both. Yeah, I know.
You got a 4 and then...
So right now you have tangent, remember the plus or minus goes to the other side, so we're okay, equals plus or minus root 3. Now Luca was saying, why don't we just change tangent squared to b? This is a Pythagorean property. You guys might have forgotten it, but it's a Pythagorean property. I know it's a gross jump, but why is Lucas still saying he likes it better? If you add the 1, what do you get? 4. And if you plus or minus square root 4, because you're trying to get rid of the squared for secant, over here you get secant is equal to plus or minus 2. And question, who is secant?
1 over cosine.
So what Luke is saying is this one you can get to cosine, which might be nice. This one, it's sine over cosine. Something's already been done. It might be a little confusing. Now, if you guys are using the table, either one would probably be about the same. If you're using unit circle out of your mind, this one's probably a little bit easier. Because we can now say cosine is equal to plus or minus the flip, which would be 1/2. So the cool thing is tangent will be plus or minus root 3 when cosine is equal to plus or minus 1/2. Now question, did you have to do both? No. Whichever one works better for your brain. Oh, well, study your unit circle no matter what, right? So question, when, if we're looking for all, when does cosine equal plus or minus 1/2, which is the same place if we were to look in our cheater table, that tangent would equal root 3 at 60 degrees or pi over 3s. So it's going to be, wait a minute, why am I right now, awkwardly with the mouse on the computer, marking all of the pi over 3s? Oh, all the quadrants. They want all of them, little stinkers. Now, it's a little bit annoying, right? But what are we going to write for all of our answers? How many are we going to have? 4. We're going to have pi over 3. I'm just going positively. Is that okay? It's easier. 2 pi over 3. 3 pi over 3. No. 4 pi over 3. Remember, 3 pi over 3 is pi. What's the last one? 1 pi over 3, 2, 3, 4, 5, right? There's 1, 2, 4, 5. 5 pi over 3. And if we look at those directions, what do we need to do to each and every one of them to make them right? Plus 2 pi n. If you were in degrees, it would be, what, 60, 120, 240, and 320? Plus 360 n. What's my answer? Whole shebang. Why was this one, don't just say there were 4 answers. Why was the process harder than the last one? We had to use the formulas, we had to use the identities. Does that make sense what I mean by the 5-1, 5-2 work was getting us ready for making these possible? Without it, we'd be stuck. How do you, I don't know, put it in your calculator, I guess. How would you put it in your calculator? You would make this one y1, make this one y2, and find the, do you remember? You would graph both of them, find the intersections. And if you were in radians, they're going to be nasty decimals. If they're in degrees, you better go zoom trig to make it expand to see all those 120s, 360s, crazy things, and go from there. Let's stop with one more example. Now this one, the directions are different, right? Am I looking for one answer, however many fit, or infinitely many? One answer, however many fit, or infinitely many? However many fit. Have they changed the rules a little bit? So I'm not just thinking about cosine inverse. They're saying, oh, no, we changed it. Now they might change it to negative 2 pi to 2 pi, 0 to 2 pi. They might change it to all sorts of stuff. I'm just giving you an example.
No,
Yeah?
you have a cosine of 2x. Is it the same as 2 cosine of x? No.
There's a special formula we'll learn for this guy in 5-4 or 5-5. But what do we do mathematically when I have 2 things multiplied equal to 0? It's going to make it harder. We could, but set each one equal. Remember factors? We set each one equal. He doesn't have parentheses, but isn't he still a factor? Isn't he still multiplied? So really, we don't really have any plugging in to do. We just get to this one at least. Now, have you seen ones in the past where you had to do the factoring? Oh, so maybe in other ones you'll have to factor and set each one equal. But once you get factors, set each one equal to 0. So we have 1 there, we have 1 here. Well, the right one looks a little more normal, right? The left one's kind of weird, got 2x that looks like it. But the right one, how would we get cosine alone? Yeah, subtract and then divide. So it would be -1 divided by 2. Are we cool on that one? Does that one look familiar, like something we might have just recently done? Maybe to the point where you could kind of just jump to the answers?
But you can't go like this.
We can't just get all of them positively. So we know where they are maybe, but we need to figure out how to write them, like which ones are legal. So let's go ahead and think about going up pi and down pi. Where were our answers for cosine being negative?
2π/3
Second quadrant.
and 4π/3.
But are we allowed to put 4π/3 if we're only allowed to do
No.
negative?
Negative 2π/3.
So we're gonna have to answer it with positive 2π/3 and negative 2π/3. And why am I separating them with commas and not putting little additions? More than one answer, and I don't want infinitely many. That's illegal.
What's the answer for the left one?
How do we think about a
I just-
2x?
Well, what if we cosine inversed it and then divide by 2?
Since we're not exactly sure what to do, we better just kind of stick with the math, and then we might have to use our unit circle scales to go further. Cosine inverse says, hey, let's go figure out what's going on with that 0 in the unit circle.
That would be
Cosine is 0 when it hits. Have
0.
pi/2. 3π/2. Oh, that's illegal.
No, negative.
Negative pi/2. Oh wait, but we're dividing by 2. Maybe we
2π/4
could.
and
Maybe we could keep going. If we want to double check, we could keep going. Why am I doing lots of answers for right now? Because I still have to do what to every single one of them? Divide by 2 or divide. Can I multiply everybody by 1 now?
but you can only have pi/4 and negative pi/4.
But can't I technically, once I divide by 2?
Oh,
This
yeah.
one now is legal. Now, wait, is this one legal? No. So I don't need to go any further positively because it's illegal. But what did I not do yet? Oh, I didn't go negative. Negative pi/2 is going to become negative pi/4. And positive 3π/4 is going to become negative 3π/4. Now guys, do you realize why homework's not due tomorrow? Yeah. Because remember 5.1, 5.2, wasn't there all sorts of funny stuff that happened that we had to... But do we have the idea of what we're trying to get to? Did the imaginary bell ring? Oh, so 30 seconds. You can use the actual bell, but mine isn't. So, homework is due on Friday. Is it a great idea to start tonight? Yes. That's up to you guys. If your spirals from last semester are trash, just trash and get new ones. Sound good? Composition books, I would like you to not throw away your old notes, but if you're transitioning to a new composition book, that's totally fine. If you want to continue, totally fine. Cool kids.
You might just stick them together somehow.
Yeah, I don't mind.
This is a long stay.
James, no, like, took
Oh yeah.
back over from. Bye guys. Happy Wednesday. You got nutrition. You're getting so fast.